and welcome to another video where I'm going to walk you through some of the trigonometric questions regarding real life situations. We see this as our level 3, level 4 type questions, and you can watch this if you just want to recap a bit on your trigonometry, or if you want to make sure that you understand everything regarding the trigonometry. So this is a consolidation of all the types that you can get in real life situations. Okay, so first up is when we start with trig, we have to write up our trigonometric ratios. So sine, cos, tan, and however you remember it. Sorry, let me just add, otherwise the teachers might get angry with me. Sine theta, cos theta, or tan theta is equal to opposite over hypotenuse. Cos theta to go and see aha, and tan is a maniki, OA, tanning over there, or you can remember it as so, katoa, or however you remember it. I'm sure your teacher has taught you many ways of how to write down the trigonometric ratios. Okay, so the first question here is, a wall is AD, which is 7.3 meters high. B and C and D are points that are on a horizontal plane, so they're all on a straight line. And then the angle of elevation from B to A are 22.3 and then 48.2 respectively. Okay, so if you want to take a moment just to capture the question, and without me trying maybe to help and guide you, you want to perhaps see if you can do it yourself. Okay, so they ask you the distance between B and C, which is over there. All right, so please remember, with trigonometry, we cannot in grade 10 work with a triangle that doesn't have a 90-degree angle in it. So it has to be a 90-degree triangle. So to find BC, we'll first have to find perhaps BD, and then CD, and when we subtract BD from we subtract CD from BD, we will find that BC that we are looking for. Okay, all right, so let's quickly work in the big triangle. We're working from this angle. Remember, it's all from which angle you are working from. We are working with the opposite. Over there, opposite to the 90 degrees, is always your hypotenuse, and this BC is your adjacent. So let's work out for BD. All right, so from that, we've got the opposite, and we are working or looking for the adjacent. So OA, can you see OA? Yep, it's tan. So tan 22,3 is equal to your opposite, which is 7.3, over your adjacent, which is BD. Okay, so if you don't know how to work that out, you can always use your triangle, speed, distance, time type of calculation. So you put your 7.3, whatever's on top of the fraction in the top, and then your two other parts of the information over there, and then it's easy to see BD is equal to 7.3 divided by tan 22.3. For those who've got science, I'm sure most of you have. Hey, okay, so then other way of working it out, you can just immediately say BD is equal to 7.3 divided by, or you can say BD times tan 22.3 is equal to 7.3, and then you divide away with tan 22.3, but this is the long way, but you can do that. Lots of kids in my class prefer to do that. And then you've got BD is equal to 7.3 divided by tan 22.3, which gives you 17.8. And because it's all meters, I'm going to write it up as meters. Okay, let's clear this thing. All right, now we want to work in this small triangle the whole time, so that we have that 90 degree that we're working with. So from here, from this angle that we know, we've got the opposite. We don't care about the hypotenuse, but we want the adjacent. So again, it's going to be tan. Let me just write this properly. So for CD, just to help you understand what I'm doing. Tan 48,2 is equal to 7.3 meters divided by the adjacent, which is CD. So I'm just going to do it quickly. 7.3 divided by tan 48.2 will give you CD, and CD is equal to 6,53 meters. And then lastly, for BC, what they are looking for was that BD minus CD, which gives you then a total of 11.27 meters. Happiness. Okay, so that's a good introduction. Now we're going to take it up a little bit. Question 2. In this diagram, B is the foot of a multi-story building, which is over there. Luckily, we've got our 90 degree. 3 people, D, E, and C, are standing at the windows on 3 different floors. They're all looking down at A over there on the ground, which is in the same horizontal plane as B. So we know that that is 90 degrees. They tell me also that AC is 9 and BC is 5. So the whole thing there. And very important, they tell me that all 3 of these angles are equal to each other. Okay. Now they say to you, prove that angle CA, so they're looking for this whole angle over here, B, is equal to 33.75. Now that is very easy. I'm just going to clear everything so that I can show you with some color. We're going to work in the big triangle because the whole A is included over here. And we've got 9 over there and we've got 5 over there. So what do we have? We have the opposite, and we've got the side opposite the 90 degree, which is the hypotenuse. Oh, and I love sin. I don't know why. Sine. So it's a sin to say oh. All right. So sine, I'm just going to call it A for a little bit easier, ease of reference. So sine A is equal to 5, the opposite, over 9. And how do we find an angle size? Remember, in your calculator, you have to shift A, 5 divided by 9. So shift sine 5 divided by 9, which gives you, let me just do that again, shift sine 5 divided by 9 gives you 33.75 degrees rounded off, which is luckily what they've given you, or they've said, prove that it is that. Okay, now they say to calculate the length of AE. So again, I'm going to clear just to show you what we are busy working with. Okay, so AE is this triangle over here. So they want the length of AE, which is this length over here. So we're looking for that. We don't have that. So remember, we always need 2 out of the 3. So we can either have the angle size there, we can have a length or a length. Okay, but luckily we know now all 3 of these. So we can easily work out for AB so that we at least have we can at least have one side out of the 3, and then I'm going to show you now how to get A, 1 and 2, or perhaps you have an idea already. So for AB, again, we don't have the opposite. I'm going to work in the big triangle for this. So I've got I can work with anything. I've got the angle size, I've got that. So let's just work with the angle size, and then that we've got 5. We've got the opposite. So we've got the opposite. We are looking for the adjacent, and we know that angle size is 33.75 because I already worked it out. So opposite and adjacent. Let's go back to our ratios. Opposite and adjacent is the tan. Okay. So tan 33.75 is equal to the opposite, which is 5 over AB. So AB is equal to 5 divided by tan 33.75, which gives you 7.48. And it's all nothing, so I'm just going to write units. So the adjacent over there, clear everything again. Oh, it's lovely to work like this. And this is 7.48. Okay, now they actually asked you for AE, which is over there. We don't have the opposite. We've got the adjacent. And perhaps we can find the angle size. So we can find AE that they are looking for. So remember they said A1 is equal to A2 is equal to A3. So if you take that 33.75 and you divide it by 3, you get that each angle, I'm just going to write it here, A1 is equal to 11.25. A2 is equal to 11.25 and A3 is also equal to 11.25. So now we know that A1 and A2, 11.25 times 2 gives you 22.5 degrees. So now we've got at least the angle that we're working from. We are not looking for the opposite. We are looking for the hypotenuse, and we've got the adjacent. Okay, does it make sense? Am I going maybe a bit too fast? So I've got the angle. I'm not looking for the opposite. I'm looking for the hypotenuse, which is AE. That's what they want. AE over the adjacent. Okay, so we are looking for the hypotenuse. Aha. So for AE, we are working with cos 22.5 degrees is equal to the cos to go and see aha, so the adjacent over the hypotenuse, which is AE. So how do we find AE again? You take the top, which is 7.48, and you divide it with cos 22.5, and you get that AE is 8.1 if you round it off. Okay, so now we've got another piece of the puzzle. I'm not going to erase that 7.48 because we've got that now, and this is 8.1. Okay, so now they say to you calculate the length of DE. DE sits over here. So I know I've got this angle size, which is again 22.5 degrees. So I can work out EB. I can work out with this one, which is 11.25. I can work out DB, and then I can just subtract the two from each other. Okay, so let me just write that out, perhaps, just so that I remember. So EB minus DB will give you DE, which they are looking for. So we need to look for the length of EB. So let me do that in that triangle. That's too much. Sorry. Let's look here. So in that triangle, I'm going to work with the 22.5, and I'm looking for the opposite. And you can either go anyway. So you've got the adjacent or you've got the hypotenuse. I like sin, so sine. I'm going to go sine. So for EB, I'm going to go sine 22.5 because I'm working in the bigger triangle is equal to the opposite, which is EB, over the hypotenuse, which is 8.1. So EB is equal to 8.1 times sine 22.5. Can you see that? Which gives you 3,099, which is going to give me 3.1 units. Okay, so I've got EB. Now we want DB. So in the smaller triangle over there, let me erase everything again and just start again. Although I'm not going to use that 8.1. Okay. So luckily I've got 11.25. I'm looking for the opposite, and I've got the adjacent, or R. So it's tan. So for dB, it's tan 11.25, which is equal to dB over 7.48. Thus, dB is equal to 7.48 times tan 11.25, which gives you dB is 1.49. Okay, so now remember the original, what we said, EB, there's EB, minus dB will give you DE. So DE is equal to 3.1 minus 1.49, which gives you 1.61 units. Oh, I hope I'm right. Okay, I'm sure I am. 3.1 minus 1.49 gives you 1.61. Okay, so that is that question. Then, question 3, the mother of all. Okay, Cape Town is a destination we wish we could all go visit soon because Cape Town is so lovely. If you are from Cape Town, give us a holler, give us a hey. The diagram below represents a cross section of the peaks of Table Mountain and Lion's Head above sea level. Points M and N are directly below peaks L and T respectively, such that MPN lies on the same horizontal plane at sea level and P is directly below C. MN is equal to 3,100 meters. Now they give this to us. They say to you, if it is given that tan theta is 0.35 and tan beta is 0.21, so they give you the trigonometric ratios. So are you with me to say that we can find theta and we can find beta? By pressing shift tan 0.35 in our calculator, we can find the angle size there for theta, and shift tan 0.21, and we can find the angle size B. But now they say to you, calculate the ratio of LM to TN and simplify your answer. Okay, let's start. Can you see, there's your one triangle. Okay, we work with a 90 degree because they told you in that all that writes up that TNM is a right angle over there because it's just below and it's the same horizontal plane, etc. Okay, so now, do you see from theta we can work out that TN, so the opposite over the adjacent, so tan theta is equal to the opposite, which is TN, over the adjacent, which is 3,100. Okay, now the same with tan beta. Tan beta is, if you are working in this triangle over here, tan beta is your opposite, which is LM. LM over 3,100. Okay. Now, if you want to simplify that, 3,100, or let's rather do this. We know that TN is equal to TN is equal to 3,100 times theta, and over here, LN is equal to 3,100. So just by playing around a bit with it, we can get to that. But they told me that tan theta is 0.35. Now, TN is equal to 3,100 times, so 3,100 times tan theta, which is 0.35. So TN gives you a distance of 1085. TN is going to give you 1085 meters. And LM is 3,100 times tan beta, which they told me is 0.21, which is LM is equal to 651 meters, which makes sense because he's shorter. Okay, but now that I've got the two distances, they told me to write it in a ratio in simplest form. So LM was 651 to the ratio Tn, which is 1085. And when you simplify that in your calculator, you should get 3 to the ratio 5. Okay, all right. So please look at these types of questions. The teachers love to ask these as your level 4 type question, where you have to play around with it, play around with what you know, and then plug it in and see what you get and see what has been given, and then replace and see if you can find what they are looking for. Okay, number B, a cable car C traveling from the top of Table Mountain T follows a path along TCM. Calculate the size of angle T. Okay, so I just want to erase what isn't needed here. I'm going to keep my lengths because that we know now for certain. Okay, so they're looking for this angle over there. All right, so do you agree? This is 90 degrees. And theta over here, we can work out. So they told me that tan theta is equal to 0.35. So if I put in shift tan 0.35, I get that it's 19,29 degrees. Okay, remember your degree sign. Okay, so now if you look at this triangle, you can find with interior angles of a triangle that angle T. So angle T is 180 minus 90 minus 19.29, which gives you 70.71 degrees. And please just add interior angles of a triangle. Okay. Now we've got that 70.71. I'm going to erase that and just put it in there. Okay, and they didn't tell me to round it off. Nay, calculate the size. Okay, cable car C travels along the cable such that TC is 300 meters. So TC is 300 meters over there. Calculate the height of the cable car above sea level at that instant, so the length of CP. So they are looking for this length. Okay, so we are going to work with let's quickly have a look. So we've got 3,100, we've got 1085. We can work out MT, but they are looking for the distance. So we must get either MP to complete this triangle so that we've got at least one more side, or we can find MC if possible so that we've got 2 out of the 3. Okay, but because they've given me this 300 over here, I'm going to check if I can work out MT to find this height over here so that I've got 2 out of the 3 for that triangle. Hope it makes sense. Okay, so let me erase everything that's not needed so we don't get confused. Okay, so we're going to first go for M. Let me get another color. Okay, so we're going to first go and try and work out for MT. Sorry that I have to go up and down again the whole time. For MT. Okay, MT, we've got the angle size, we've got the opposite. Okay, so those we've got, so then we can work out MT. So we are looking for the hypotenuse. So remember that's all the length, the whole length from M to T over there. So opposite and our hypotenuse, my favorite sign, I don't know why, I always like sign. So sine 19.29 is equal to the opposite, which is 1085 over MT. So MT we can get by taking 1085 divided by sine 19.29, which gives you 3,284,398, which makes it a rounding off to 40. Just want to make sure, is it meters? Yes. Okay, so there we've got MT, but they told me that CT is 300. So minus CT, which was 300. So 3284.4 divided by 300 gives you that MC is equal to 2,984.4 meters. Okay. So that's quite important. And people use color. Use highlighters. It's your work. As long as you know what you're doing and, can understand what's happening. So I just want to quickly make sure. 3284.4 minus 300 gave you that 2984.4. Okay, so now we've got this as 2984.4 as MC. And I did label it MC. Yes. Okay. So now what they were looking for was CP over here. So CP is, so now if we look at this triangle over here, we've got the opposite, what we are looking for, CP. And here's your 90 degrees, which gives you the hypotenuse. So again, sine 19.29 is equal to the opposite, which is CP, which we are looking for, over the hypotenuse, which is 2984. Thus, CP is equal to 2984.4 times sine 19.29. So CP is 985,9 rounded off meters. And that is it. That's all the level 4 that I've got for you. Well done for watching. I know some of my smarter kids will have a look through this because they're always on the ball. They want to make sure that they understand everything, and that's excellent. So well done for watching. And please reach out if you need to know or need to ask anything. And yeah, hope you have a great day further. Thank you for watching. Bye.